discussing about the conservation of momentum. So regarding the application of the conservation of momentum, so yesterday I have discussed about the two or three applications, that is the explosion of bomb or jumping from the car and firing a bullet. So these are already discussed in yesterday class. So today we will discuss some more application from the conservation of momentum. Okay. So let us start with this. So let us say this is the problem. So there is a block of 4 kg and there is another ball of 1 kg mass is there. Now you are asked to calculate find the speed of 1 kg and 4 kg when 1 kg leaves the bigger. That means once you release this, so if you release this, then this ball will come down in this direction. So ultimately, it will move in this direction finally. Okay. So you are asked to calculate the velocity of the ball as well as the velocity of the bigger. Okay. Let us say I am saying that whenever I know that, so this problem I have already dealt yesterday, that whenever there is one block and another block is there, if I say the ball is coming down, so the mass will move in this direction. Okay. So mass of 4 kg will move in the opposite direction. So let us say the velocity of the 4 kg is, let us say, v. Okay. And the velocity of the ball once it's leaving the bigger block is, let us say, v1. Okay. And that is the velocity with respect to, let us say, the graph. Okay. So applying the conservation of momentum. So momentum of one initially, what is the initial momentum? That is 0, because initially entire system is rest. So that should be equal to final momentum. Since no net force is acting along the x direction. So I am applying the conservation of momentum along the x direction because there is no net force along the x direction. So can I say that 1 into v1, that means 1 into v1 is the momentum for the ball minus 4 into v2 is the momentum for the bigger block. That should be equal to 0. Okay. So what you can say that v1 should be equal to 4 v2. This is the relation between the velocity of 1 and velocity of 2. So this is the first relation that I am getting. So since I have to calculate both v1 and v2, so there must be another equation. So only one equation, that is the conservation of momentum, will not give the answer. So I have to get another equation. So what is that another equation? That is the work energy. Okay, so I have to apply the work energy theorem concept over here also. So now initially the potentiality is how much? So ball is at a distance of 10 meters from the ground. So initial potential energy U1 should be equal to mgh. That means 1 into g into h means 10. So that is 100 joule. Okay. So initial potential is 100 joule. Final potential is how much? So if I say ground is the reference frame, so initially the ball and the coming down to the ground. So final potential is 0. Kinetic energy initially there is no kinetic energy. Initially there is no kinetic energy. So that is the kinetic energy is 0. Now what is the final kinetic energy? Final kinetic energy is that is 1 kg block is moving with the velocity v1. That is half into 1 into v1 square plus half into 4 into v2 square. Okay, this is the final kinetic energy. So what you can see, the initial potential plus initial kinetic, that should be equal to final potential plus final kinetic. So 100 plus 0, that is the total initial energy, that should be equal to final kinetic energy plus potential energy. That means that is equal to half into v1 square plus half into 4 v2 square. So this is the second equation that we got. Okay. So solution of equation 1 and equation 2 will be the value of v1 and v2. Okay. So if I simplify this, I am getting that v1 square plus 4 times v2 square, that should be equal to 200. Okay. And I have said that v1 equals to 4 v2. So if I use 4 v2 square over here, that is 16 v2 square plus 4 v2 square, that should be equal to 200. That means v2 square equals to 100. That means v2 equals to 10 meter per second. So the velocity of the bigger block, that is 4 kg per second, will move with the velocity of 10 meter per second in the left direction, and correspondingly velocity of 1 should be equals to 4 v2. Not 10. So it is 20 v2 square equals to 200 is root 10. Root 10. v2 equals to root 10. Correspondingly, v1 should be equals to how much? 4 root 10. So these are the two answers. Okay. So whenever you are asked to calculate the velocity, then you have to apply first equation as the conservation of momentum. And applying this two, you get the answer. Okay. Now coming to the next situation, here the same question is there, but Now the concept is that what is the difference between these two? So earlier situation, once the ball is moving down, so the velocity of the ball becomes horizontal. Like it. I mean, this velocity that I am taking is basically with respect to ground. With respect to ground. Okay. But now the velocity of the ball or the 1 kg block as it is moving down, it is not horizontal. No. Let us say it is moving with a velocity v1. So in this direction, the velocity of v1. And at the same point of time, the velocity of the 4 kg, let us say v2. Okay. So v1, what is v1? v1 is the velocity of 1 kg with respect to 4 kg. So v1 is with respect to 4 kg. So theoretically, this 1 kg has two different velocities. One is along the plane, another is along the v2 direction. Okay. So there is another velocity v2. So corresponding to this, there is one relative component, that is the VR is the resultant velocity. So this is the velocity, okay, of the 1 kg block. So since in this situation also net force along the x direction is equals to. So conservation momentum is applicable along the x direction. So what is the net force acting on the, what is the net momentum along x direction? So for that, initial momentum is 0 again. Initial momentum, that means that is equal to final. So I have to calculate the final momentum along the x direction. So for V2, that is a 4 kg, that is the x momentum. But for the 1 kg, there are two components of velocity. One is V1 and one is V. Okay. So V1 has one component that is along x direction. How much? V1 along this direction is V1 cos 37. Nah. So this angle is 37 degree.
Yes,
So
sir.
that is 4 V1 by 5. Why I am taking that? Because I have to apply the conservation momentum along the x direction. So 4 V1 by 5 is the component of velocity along x direction. And what is that velocity? That velocity is nothing but v2. Okay. So if I apply the conservation momentum, final momentum should be equals to 1 kg has two different values. 1 into 4 v1 by 5 minus 1 into v2. That is the momentum of the 1 kg along the x direction. Okay. And plus, or not plus, minus 4 into v2. Why minus? Because v2 is taken to the negative direction. So that is equal to 0. Okay. So ultimately what I am getting that 4 by 5 v1 should be equals to 5 v2.
Okay.
4 by 5 v1 equals to 5 v2. So this is the first equation, that is the relation between v1 and v2 is known. So v1 equals to how much? 25 v2 by 4. This is the first equation. Then the second equation has to be obtained from the energy conservation. Second equation has to be obtained from the energy conservation. So potential energy, loss in potential energy is mgh. How much? 1 into 10 into 10. Okay, that is the loss in potential energy. That is equals to gain in kinetic energy. That is equals to gain in kinetic energy. Now kinetic energy is gained by both 1 kg and 4 kg. But 1 kg has two different velocity. One is v1 and another is v2. Okay. One is v1 and another is v2. So relative component, what is the relative velocity? Vr, can I say Vr equals to under root of v1 square plus v2 square minus 2 v1 v2 into cos of 37 degree.
Yes, sir.
Okay. Why? Because this angle is, how much? This angle is 180 minus 36. So cos of 180 minus 37 is minus cos 37. So that is the Vr now. So gaining kinetic energy is gained by 1 kg. How much? Half m into Vr square. This is the first velocity. And then half into 4 kg into v2 square. This is the final kinetic energy. Okay. So that means half, this m is 1 into Vr square means v1 square plus v2 square minus 2 v1 v2 into cos of 37 means 4 by 5 plus 4 v2 square, that is 2 v2 square. Okay. So this is the second equation, that is 100 equals to this equation. Okay. So again I am getting the relation between v1 and v2 and there is another equation. So solving of these two equations will give the v1 and v2 separate. Okay. So if I solve equation 1 and 2, you can get the value of v1 and v2 separate. Moving on to the next situation. So let us say there is a system of this kind. So again the mass is 4 kg and 1 kg block is pushed with a velocity of 10 meter per second. Okay. Now you are asked to calculate the maximum height attained by the smaller block. As the smaller block moving, so that means ultimately the smaller block will move in the upward direction. Right? So it will move continuously in the upward direction until and unless the upward component of velocity becomes zero. Once the velocity along the y direction becomes zero, up to that particular point, it is moving. Nah, because it is the max that is the maximum height attained by the particle. Then. Now, at that point of time, what is happening? At that point of time, both 4 kg, let us say 4 kg will start to move with the velocity v, and it will move with the same velocity v also. Got it? So, the maximum height attained by the block is such that at that point of time, the block of mass 1 kg should move at a certain height so that at that particular height, Vy should be equal to 0. And in that
Yes.
situation, the block and the 4 kg, both 1 kg and 4 kg should move with the same velocity. Okay. So if I apply the momentum conservation, so what is the initial momentum? Initially, momentum is 1 kg is moving with 10 meter per second and 4 kg is at rest, so 4 into 0. So that is a 10 is the initial momentum. That should be the final momentum. So P final should be also equals to 10. What is the P final? That is 1 kg should move with the velocity v plus 4 kg also move with velocity v. That means what I can say it is 5v. So 5v equals to 10. Huh? That means v equals to 2 meter per second. So once the original component of the velocity becomes 2 meter per second, then I can say the particle is at its maximum. Let us say that at h, height is h, you want to calculate that. Now, in order to calculate that h, you have to again apply the work energy conservation. So, initially kinetic energy is how much? Half into 1 into 10 square. Okay. So, that should be equals to final potential energy. Potential energy is gained by the 1 kg mass, that is 1 into g into h and kinetic energy. What is the kinetic energy? At the final situation, both 4 kg and 1 kg, that is half into 4 plus 1 is moving with velocity v square. Okay. Where v is 2 meter per second, so 5 into 4 by 2 means 20 by 2 means 10. 5 into v square means 4. So 5 into 4 is 20. 20 by 2 means 10. So that number is 10. And it is 10 square means 100 by 2 means 50. That should be equal to 10h. Okay. So I am getting 10h equals to 40. So that means h equals to 4. So the block of mass 1 kg will rise up to height of 4 meter before coming to stop. So maximum height attained by the particle is 4 meter. Got it?
Okay.
Okay, so there is another way of solving this problem. So first, what you do, we use the conventional approach, that is the method number 1, where we approach it in this way so that we can apply the conservation of momentum first. And conservation of momentum is applicable only along the x direction. Why? Because along x direction, net force is net force is 0 along x direction. So that's why I am applying the conservation along the x direction. Okay. Now there is another approach to solve this problem. What is that approach? That approach is called the center of mass. Because I am inside the center of mass chapter, so I should practice this particular approach to solve the problem with much ease. Okay. So what is that approach? So for that, so you have to view the entire thing from the center of mass reference. Okay. So initial momentum is what? Initial momentum is 10 kg meter per second. Okay. So that means initial momentum is not equals to 0. That means what you can say center of mass is not at rest. Center of mass is not at rest. So my task is to calculate what is the velocity with which the center of mass is moving. Okay. So initial momentum is 10 kg meter per second. So there is a momentum is 10 kg meter per second. That should be the momentum of the center of mass. What is the center of mass velocity then? 4 plus 1 is the total mass into velocity of center of mass. Okay, that will give the value of center of mass velocity. What is the center of mass velocity? Center of mass velocity comes to be as the 10 by 5, that is 2 meter per second. Okay, so 2 meter per second is the center of mass velocity that we have already got. So the particle initially the center of mass is moving 2 meter per second along x direction. Now, initially center of mass, this is the, let us say this is the center of mass. Center of mass is moving in the x direction with the velocity of 2 meter per second. Okay. So finally, it should move with the same speed 2 meter per second. Why? Because initial momentum is 10, so final momentum is also 10. No, final momentum is also 10, so center of mass should move with constant speed because there are two conditions. If net force is 0, either the center of mass will be at rest or it will move with constant speed. That means initially it is moving 2 meter per second along the x direction. That means finally it should move with the same 2 meter per second, but now it should be in the y direction. Why? Because since the center of mass is moving along the x direction, So ultimately the block will rise in this direction, so that you understand. And ultimately it will rise up to a certain height so that entire energy is converted to the potential. Initially, the block has energy with respect to center of mass, that is the kinetic energy. Okay. So initial kinetic energy, I want to calculate the initial kinetic energy, but with respect to center of mass. With respect to center of mass. How to calculate that? So for that, so with respect to center of mass is moving with the 2 meter per second and the block is moving with the 10 meter per second. So velocity of block with respect to center of mass should be 10 minus 2. No. So that means half into 1 into 10 minus 2 whole square. That is the velocity of the block with respect to center of mass, 1 kg. And 4 kg is rest. That means 4 kg is from the center of mass frame. What I say, that 4 kg is moving towards the center of mass with a velocity of 2 meter per second. No. So with respect to center of mass, velocity of 1 kg is 8 meter per second in the positive x direction and 4 kg is 2 meter per second in the negative x direction. So what is the velocity of the 4 kg with respect to center of mass? That should be equal to half into 4 into 2 square. Okay. So what is this number? That should be equals to 10 minus 2 means 8 square means 64 by 2 means 32 plus 4 into 8 means 40. So that is the initial kinetic energy of the system with respect to center of mass. Okay. So the block will rise until and unless interkinetic energy is converted to potential. So final potential energy with respect to center of mass again should be equals to then 40. Okay. If that happens, that means now there is entire energy is converted to the potential energy form so that the block will stop to rise. So final potential energy is also 40. Now what is that energy? That should be equals to M means 1 into G into H. That means again I am getting the same height 4 meter. Okay. But this is a new concept, that is you want to calculate the kinetic energy with respect to center of mass difference. Now whenever I want to calculate the kinetic energy with the center of mass, so let us say if I say this is the 4 kg, so I draw it simple way 4 kg and this another 1 kg is placed over here. Okay. So let us see this is the center of mass. So center of mass is moving in this direction with a velocity of 2 meter per second. Okay. 1 kg moving in the same direction as 10 meter per second. Now, with respect to center of mass, if I place the observer on the center of mass, with respect to center of mass frame, so velocity of 1 kg should be 10 minus 2, and velocity of 4 kg will be minus 2 then. Why? So velocity of any particle, let us say A, with respect to center of mass, should be equal to how much? dA minus dc. Yeah. So I want to calculate the velocity of 1 kg with respect to center of mass. Let us say this is the A block, and this is the center of mass is C. So velocity of A with respect to C should be how much? dA minus dc. So what is dA? dA is 10 and dc is 2. That is the similarly velocity of B block. Let us say this is the B block. So BC should be equal to B dB minus dc. But dB is 0. So then minus 2. So that means B and the 4 kg is moving toward the center of mass with a velocity of 2 meter per second. So that is the idea to calculate the kinetic energy with respect to center of mass. And once you calculate the kinetic energy center of mass, kinetic energy with respect to center of mass, that means entire kinetic energy with respect to center of mass has to be converted to the form of potential energy so that the particle will rise up to that much. Okay. So this is the next step. Now, the same approach can be converted to concept of reduced mass. Okay. So this is the third method. That is called the reduced mass concept. Now, what is that concept? Reduced mass is a concept which tells us to calculate the kinetic energy with respect to center. Let us say consider a spring block system. Let us say consider a spring block system. Let us say M2 is moving with a velocity V0 and M1 is at rest. Initially M2 is moving and M1 is at rest. So if I calculate the center of mass velocity, let us say this is the center of mass position. I want to calculate the velocity of center of mass. So what we write? The total mass, that is M1 plus M2 into velocity of center of mass, Vc, that should be equal to the initial momentum. Initial momentum is only M2 has velocity, that is M2 into V0. What is Vc then? Vc should be equal to M2 into V0, thereby M1 plus M2. Okay, that is the velocity of the center. Now, with respect to center of mass, if I say velocity of center of mass is Vc, so with respect to center of mass, what is the velocity of M2? M2 is moving in this direction with the velocity of V0 minus Vc. And M1 is coming towards the center of mass with the velocity of Vc. Okay. So these are the velocity of M1 and M2 with respect to center. So with respect to center of mass, I want to calculate the kinetic energy with respect to center of mass. Initial kinetic energy with respect to center of mass. So what is that number? That should be equal to half m2 into v naught minus vc whole square plus half m1 into vc square. Okay. So this is the initial kinetic energy with respect to center of mass. So now put all those values. So half into m2 is there. Now v naught minus vc, and vc is this number. So v naught minus m2 into v naught divided by m1 plus m2 whole square plus half into m1 into m2 into v naught divided by m1 plus m2 whole square. Okay. If I simplify it, so I am getting this number v naught minus this number. So ultimately m2 will cancel out. So we are left with m1 into v naught by m1 plus m2. Okay. Half into m2 into m1 into v naught divided by m1 plus m2 whole square. This is the first part. And second part is half into m1 is common, and bracket within bracket m2 into v naught divided by m1 plus m2 whole square. Okay. So if I take m1 m2 by m1 plus m2 common, so I am writing over here. So kinetic energy is just the center of mass plane. If I say half into m1 m2 divided by m1 plus m2, if I take it common, so ultimately I am getting first number is how much? First number m2 into m1 v naught square. m2 into m1 into v naught square divided by m1 plus m2. Okay, this number. And then another number is m1 into m2. So it should be only m2. So first number, so I have taken the m1 into common. So m1 into common means there is no m2. So only m1 by this number. And the next number is m2 by m1 plus m2. m2 divided by m1 plus m2 into v naught. Okay, so take v naught square common. So ultimately the numerator m1 plus m2, denominator is m1 plus m2. So it will cancel out. Okay. So ultimately this number is simply v naught square. So what I am getting that half into m1 plus m1 into m2 divided by m1 plus m2 into v naught square. So this is the kinetic energy. Okay. Now this number is called the reduced mass. Written by the name. So kinetic energy with respect to center of mass formula is half into mu into v naught. What is mu? Mu is the product of the mass m1 and m2 divided by m1 plus. Okay. So that concept is called the reduced mass. So that concept can be applied over here also. If I apply the same concept, what is the new number for this situation? So mu should be equal to m1 m2 divided by m1 plus m2. Okay. So it is equals to 1 into 4 divided by 4 plus 1. That means 4 by 5. Now why it is called reduced mass? Because the number mu that I am getting is always less than either of m1 and m2. It is always less. So mu becomes 4 by 5. So what is the kinetic energy? Initial kinetic energy with respect to center of mass should be how much? That should be equal to half into mu into v naught square. What is the v naught square number given? That is 10 meter per second. So this number is v naught. Okay. So half into 4 by 5 into 100. That means 40 joule. Okay. So this is the 40 joule. That means the entire kinetic energy has to be converted to potential energy. So 40 joule should be equal to our MBL. Okay. So from that again I am getting the 4 meter. Okay. So these are the three approaches by which I can solve this type of problem, where the best method is the third method. So here I am seeing that there are two multiple objects are there. Both are moving. Both are moving with some different velocity v1 and v2. Then you have to apply the concept of the reduced mass. Okay. Now what is the another concept of reduced mass? So if I say the reduced mass is this mass, so kinetic energy can also be from the reduced mass is that half mu into VR square. What is VR? VR is the radius. Okay. Let us say the m2 is moving with velocity. Let us say m1, m2 is moving with velocity v2, and m1 is moving with velocity v1. So radius should be v2 minus v1 or v1 minus v2. Which one is higher? Okay. So always use this formula to calculate the kinetic energy with respect to center of mass frame. So that will make the problem easier. Okay. Understood?
Yes, sir.
So now the next part of this problem is that you are asked to calculate the distance traveled by 4 kg when 1 kg is in air. Okay. Why? Because now I reduce the height as 2 meter. I already calculated the same problem that I see that the block will rise up to height of 4 meter. But once you restrict the height to 2 meter, that means now once the body is reach, once you reach over here, the y component of velocity is still there. No, it is not equal to 0. So y component of velocity will be 0 at 4 meter height. But at 2 meter height, y component of velocity is there. Okay. So I want to calculate what is this y component of velocity. So I know that with respect to center mass reference frame, with respect to center mass reference frame, and center mass velocity is not going to be changed. No, center mass velocity is not going to be changed. That means initially I already calculated the velocity of center mass is 2 centimeter, 2 meter per second. So finally it should be also 2 meter per second. That means once the block is leaving the 4 kg support, so that means it has the velocity along x direction as 2. So that should be equal to 2 meter per second, that is center mass velocity. And 4 kg is also moving with the same velocity, therefore 2 meter per second. Okay, why? These are the velocity of the center of mass that remains same. I am calculating entire thing with respect to center of mass reference frame. So that is the idea. That means all the blocks are having the x component of velocity that is equal to 2 meter per second. Okay. Only thing is that initially the kinetic energy is only for the 1 kg and finally kinetic energy comes between the 4 kg and 1 kg. Again, we apply the concept of work energy theorem. So initial kinetic energy is how much? Initial kinetic energy half into 1 into 10 square. Okay. That should be equal to final kinetic energy. Final kinetic energy is half into 1 half velocity is 2 meters square 1. Another is half into 1 into Vy square. Okay. So this is the kinetic energy 1 kg and kinetic energy 4 kg is half into 4. That is the kinetic energy 4 kg and potential energy of the 1 kg is how much? mdh. That is m is 1, g is 10 and h is 2 meters. So on the left hand side I am getting 50. That should be equal to how much? 2 plus Vy square by 2 plus 8 plus 20. 8 plus 2 means 10, 10 plus 20 means 30. So Vy square becomes 40. Vy square becomes 40. So Vy becomes how much? Root 40. Okay. So once the 1 kg is leaving the surface, that means it should have a velocity of root 40 meter per second. Okay, root 40 meter per second. So ultimately the particle will reach this point and after that it will form a projectile path. Okay, you form a projectile path. So you are asked to calculate the distance traveled by the 1 kg. When distance traveled by the 4 kg when 1 kg is in air. So what is the time of flight for that? So can I say time of flight for the entire projectile is 2 times of Vy by g. That means 2 times of root 40 by 10. Root 40 by 10. So this is the time of flight. And within that time of flight, what is the distance traveled by the 4 kg? That means 2 into that number. So this is the distance traveled by the 4 kg. This is the distance traveled by the 4 kg. What is that distance? That should be equal to 2 into capital T. That is the range basically. Understood? So 2 is the velocity of the 4 kg. That is the original component. With that component, how much distance traveled? Multiplied by T. Capital T is this number. So ultimately your answer should be 2 into 2, 40 by 10. So it is 4 and 40 means 2 root 10. 2 root 10 divided by 10. That means 8 by root 10. That will be your answer. Okay.
Okay.
The distance traveled by the particle once it is in air. Okay. So I have approached this in a conventional. Again, we can approach the same problem with respect to center of mass. If I calculate with respect to center of mass, what you know that initially the velocity or initial, so for this system mu is how much? Mu is m1 into m2 means 1 into 4 divided by 4 plus 1. That is 4 by 5. That is a mu number. So initial kinetic energy with respect to center of mass. How much? Half into 4 by 5 into 10 square. Half into 4 by 5 into 10 square. That means 100 by 10. 100 by 10 is 10, 40. So 40 is the initial kinetic energy with respect to center of mass. So final kinetic energy is equal to center of mass. Final kinetic energy is equal to center of mass. Now finally, both are moving with 2 meter per second. Both are moving 2 meters per second, but it has a velocity along the y direction. Okay. So final kinetic energy is equal to center of mass should be it should be equals to half into Vy square, 1 into Vy square, 1 into Vy square, that is the velocity, plus half into 1 into 2 square, plus half into 4 into 2 square, this number. But that energy is calculated based on individual ground flare. But I have to calculate the kinetic energy with respect to center of mass. With respect to center of mass, 4 kg has no component of velocity. Why?
Yes.
Because 4 kg is moving, so center of mass is moving 2 meters per second. So that means 4 kg is moving with respect to center of mass in the opposite direction. So these are also moving in the same opposite direction. But Vy has one component. With respect to center of mass, Vy has one component. So I can use this formula also. So ultimately, same answer I will get. What is the potential energy? What is the and again you have to add the potential energy also over here. This number. Ultimately, I am getting same answer. Okay. So you can approach the same problem by different method, but only thing you have to take care about the situation that whenever you are applying the center of mass concept, that means you have to take care about the center of mass. Okay. Now moving on to the next situation, let us say there is a so in this problem there is a car and there is a ball which is hanging from the car itself. Okay. You are asked to calculate the velocity of the car when the string makes an angle 37 degrees with the vertical. So if the string oscillates, if the string oscillates, then it will give one momentum transfer to this 4 kg car. So because of that 4 kg move. Okay. So initially the ball is at an angle 53 degree. Ultimately one point will come when the ball is making an angle 37 degree. So at that point, let us say the ball is moving with the velocity of u, and that u is with respect to car. With respect to car. Okay. And at that point, the cart is moving in the opposite direction with the velocity v. Okay. So what you can say that if I do the momentum conservation, the initial momentum is 0. Ti is your entire mass is your place. Okay. So final momentum should be equal to how much? 4 kg is moving in the opposite direction. 4 kg is moving in the opposite direction. So can I say it is equal to 4 v with a minus sign? Or say that is the plus 4. Okay. And for 1 kg, it is negative, let us say. Okay.
Yes, sir.
So 1 kg is moving with how much? So along the x direction, you have to apply the conservation momentum. So x component of velocity, x component of velocity is this much. So what is this angle? This angle is 37 degree. So this 50, that means this is also 37. Okay. So u cos 37 is the x direction. So 4u by 5 in the horizontal direction. And minus v. Why minus v? Because it is with respect to cart. Okay. So velocity of let us say a with respect to cart is equals to how much? Va minus vc. Okay. I want to calculate the va number. What is that va? That is the velocity of a with respect to ground.
Ground.
So va should be how much? Vac minus
Plus.
vc. So VSC is how much? VSC is equals to 4u by 5. And VC is how much? V. Okay. So if I take V, this is the positive side, so it should be how much? Minus 4u by 5. Okay. Minus 1 into 4u by 5. 4u by 5 plus, not plus, it should be minus V then. Like this, na? So that is equal to 0. So from that, what I am getting that 4v minus 4u by 5, so that is 5v. So this is equal to 3v, 3v, not 3v, 5v. So 5v equals to how much? 5v, 4v plus v, that is 5v equals to our 4u by 5. Okay. So or I can say v equals to 4u by 25. This is the first equation that I am getting. Okay, this is the equation number. Okay, this is the relation between V and U. Now calculate the energy conservation. Energy conservation. So initially, what is the kinetic energy? So initial kinetic energy is G because the entire system is very less. So final kinetic energy. So for final kinetic energy, so 4 kg is moving with the velocity V. So half into 4 into V square. But this 1 kg has two component of velocity. 1 kg has two component of velocity. So what is that? So if I say the velocity of the particle, so u is the, so if I say this is the u component of velocity, u. So vectorially you have to add that number with v. So v is in this direction. Okay, v is in this direction. So
Okay.
ultimately this angle is how much? This angle is 37 degree. Original component is 37 degree. So this is 180 minus 37. Okay. So velocity of 1 kg you just put down should be the resultant of this two. Let us say this is the velocity of p particle p. Okay. So that should be equal to half into 1 into Vp square. Okay, this is the final kinetic energy. And there is a change in potential. Now, what is that Vp number? If I simplify this Vp number, that should be equal to V square plus U square minus 2V into E into cos of 30. This is the Vp number. So, if I put that Vp numbers, I can get the value of final kinetic energy. And what is the potential energy? Potential energy of the system is dropped by this much distance. Okay, initially the particle is 53 angle. Now the particle is at this angle. So, this is the drop in potential. What is that drop? That is cos 53 minus cos 37 minus cos 53. Can I say this height is basically our L is 1 meter. So 1, so if I say this is our H number, so H is the drop in potential height. That should be equals to 37 minus 53. Cos
Okay.
of 37 degree minus cos of 53 degree. Into 1. What is that number? That is 4 by 5 minus 3 by 5 into 1. That is 1 by 5. So drop in potential. Drop in potential is how much? mgh. 1 into g into h is 1 by 5. Okay. There is a drop in potential energy.
Okay.
Understood?
Okay.
So ultimately it gives value is how much? There is a 2. So this drop in potential energy, that should be also gain in kinetic energy. So gain in kinetic energy is final kinetic energy. So ultimately you have to getting that the potentiality is dropped by this 1 kg particle by 2 joule, and that should be gained by the kinetic energy. So if you equate these two, that means that should be also only final kinetic energy. So from that you can get another equation. So if I get equation number 2, so once I solve equation 1 and equation 2, I can get the value of u and v separately. Okay. So these are the some typical problem that you have to understand whenever you are dealing with the central mass problem. In central mass situation, what is happening that every time there are two bodies. Okay, one is moving, another along with that another body is moving. So whenever you are applying the conservation of linear momentum, first of all you have to understand in which direction you are applying. So in this situation, net force along the x direction is cancelling. Okay, so there is no net force along the x direction. So only thing is that force is not net force is zero along the x direction, so that I can apply the conservation along the x direction. So for that, I have to take the component of this because once the particle is moving down, so the U has one component along the x direction, that is 4 U by 5. And another component, so parallel it is moving in the forward direction, and as the car is moving in the backward direction, it has another component of velocity in this direction with the V. So 4 U by 5 minus V is the net velocity. Okay. So there is the mass momentum conservation first. So once I write this momentum conservation, then I have to apply the energy equation also. For energy equation, you have to be applied in such a way so that every time one particle has two different velocities. One is u, another is v. So to take about the resultant of this, once I take the resultant of u and v, then I can get the Vp. That Vp has to be used in kinetic energy calculation.
Okay.
Understood?
Okay.
Let us say now I want to calculate another type of situation where there are two balls, mass of 1 kg and 2 kg are connected by a rod. Okay, they are fixed with the rod, and the entire thing is in the horizontal plane. So this is the horizontal plane. You placed it on a table, and then you allow this 2 kg to move with a 10 meter per second. Okay. So once you allow the 2 kg to move with 10 meter per second, you are asked to calculate the tension in the rod. How to calculate that? Now for that situation, if I see this is the center of mass, if you see this is the center of mass, let us say the distance between 1 kg and 2 kg, let us say 2 meters. Okay. So these are the 2 point masses. So from the concept of center of mass, I can say this distance is how much? This distance should be equals to 1 into 2 divided by 3. Now, this distance is 1 into 2 divided by 3. I mean 2 by 3 meter. 2 by 3 meter. So that means this distance is 4 by 3 meters. So this is the center of mass. Now I want to calculate what is the velocity with which the center of mass is moving. Let us say center of mass is moving very quickly. Okay. So can I say the VC should be equal to how much? 2 into 10, that is the momentum of the 2 kg, plus 1 into 0, that is the momentum of the 1 kg, divided by 2 plus 1, that means 20 by 3. So 20 by 3 is the velocity within the center of mass of movement. Okay. Now the problem is like this way. There is a rod who this point is moving with a velocity of 10 meter per second. Okay. And the center of mass is located over here, and the center of mass is moving with a velocity of 20 by 3. Now, this point is there. Okay. Now, I want to calculate what is the tension. For that tension, so you have to calculate. Now, in this situation, what is happening? The rod is not in the linear position, it will rotate. Why? Because the linear component of velocity is different. So, it will try to rotate. Now, what is the omega number for this situation? What is the omega number for this situation? Now, if I want to calculate the omega, so omega is angular speed, that is equal to, I know that v perpendicular relative divided by r. So what is the v perpendicular relative? That is 20 by 3 minus 10 divided by r. R is what? R is the distance between these 2 points, that is 2 by 3. Okay. So that number is omega. So that is how much? 20 minus 30 means 10 by 3. So ultimately become minus 5 radian per second. Okay. That means the particle will rotate in this direction with the omega speed. With the omega speed. So because of this omega, now the tension will come. Because of this omega, the tension will come. So what is the tension? So for this situation, what I say, if I say this is the tension, so tension will be balanced by the m omega square r. Nah. So T should be equals to m omega square r. Now what is this m? M is 2 kg. What is omega? 10. Not 10, 5 square. Omega is 5, so 5 square. And R is how much? R is 2 by 2. So ultimately what I am getting, that is equals to 25. So it is 100 by 3 Newton. Okay. So the omega that I am getting, it is the omega of the center of mass. So the entire system will rotate about the center of mass with the omega of, that is 5 radian per second. Okay. Understood? So if I take about this radius, so if I say this is the distance 4 by 3, 4 by 3 meter. So this point is also moving with the m omega square. So for this, what is the tension? If I say this is the T, so then it should be equals to m omega square r. Okay. Now what is this number? M is 1 kg. Omega square is 25. And R is how much? 4 by 3. That is again 100 by 3. The same tension I will get. Whether I do the analysis on the 1 kg or 2 kg, I have to get the same answer because the tension inside the rod should be same. Not going to change. Okay. So it is a typical problem where I have to apply the concept of relative angular speed. So relative angular speed means there is a linear motion of 2 different points. So they are moving. So that means there must be some kind of omega between them since the velocities are different. If I see the problem is like this, let us say there is a body. Let us say is 1 kg and this is also 1 kg. So both are moving with same velocity. Let us say it is moving 10 meter per second. It is also moving 10 meter per second. Okay. Then, since the velocities are same, so what is the relative component? That is 0. That means for this situation, the omega will be 0. Okay, in this situation, omega will be 0. But in this situation, one particle is moving 10 meter per second and the center of mass is moving 20 meter per second, 20 by 3. So that means there must be some kind of tension. Once I calculate that omega, then only I can calculate what is the tension inside the string. Understood? Okay. Now moving on to the next segment of the center of mass. Now we discuss about the spin block system. Okay, the spin block system is a typical problem which has a large variety of situation in under the center of mass. Okay, the center of mass chapter has a special segment for to deal with the center of mass or to deal with the spring block system. So spring block system means there must be two blocks. There are two blocks. So two blocks are connected by the spring, and you are giving a movement or velocity to one block. Once the velocity is given to one block, now you are asked to calculate what is the velocity of the other block, what is the elongation, what is the compression, everything you are asked. Okay, so let us start with this situation. So first type of problem is, in this type of problem, you are asked to calculate the range of speed for both 2 kg and 1 kg. Okay, so initially 2 kg is given a speed of 15 meter per second and 1 kg is at rest. And spring constant is given as 100 Newton per meter, and they are kept in a smooth horizontal plane. And once I push them, so you are asked to calculate what is the maximum and range in the maximum and minimum velocity of 2 kg and maximum and minimum velocity of 1 kg. Okay, now based on center of mass reference frame, so if I say this is our center of mass, so if I come to the center of mass, so first task is to calculate the center of mass velocity. So velocity of center of mass should be how much? So 2 into 15 is the momentum for the 2 kg. 1 into 0 is the momentum for the 1 kg. Divided by total mass is 2 plus 1. That means 30 divided by 3, that is 10 meter per second. Okay. So center of mass is moving with 10 meter per second. So now come to the with respect to center of mass situation. So let us say there are two blocks. So they are connected with the spring. They are connected with the spring, and the center of mass is somewhat over here, and the center of mass is moving in this direction with a velocity vc, that is equal to 10. Now with respect to center of mass, this 2 kg is moving in this direction with a velocity of 15 minus 10, that is 5. And with respect to center of mass, 1 kg is moving in the opposite direction with a velocity of 10. Nah, 1 kg is moving in the opposite direction with a velocity of 10. So the particle, let us say for any particle, velocity of particle with respect to center of mass should be how much? Vp minus this. So if I want to calculate the velocity of particles, so velocity of particles should be equal to Vpc plus Vc, that number. So I am going to calculate the Vp number, that means the velocity of particle with respect to center of mass plus velocity of center of mass. Okay. Now velocity of particle with respect to center of mass is 5. Now, let us say focus on the 2 kg particle. So if I say 2 kg particle, for 2 kg particle, so Vpc number, that is the maximum possible value of Vpc. Maximum. So maximum is 5 because initially 2 kg is given a value of 50 meter per second. So that means it cannot move beyond 50 meter per second. Maximum speed is 50 meter per second. So Vpc maximum for the 2 kg should be how much? 5. 5 in this direction. Okay. Now Vc, velocity of center of mass, that is fixed. Velocity of center of mass is how much? That is 10. It is in this direction. Okay. So if I add these two numbers, that will give the velocity of Vp max. That is already given, that is 15. Okay. That is one answer. Okay. And it is in this direction. Now Vpc max, that is 5, can be also in the opposite direction. Why? Because after some point of time, the 2 kg move in the opposite direction. If you see the animation, so let us say this is a 1 kg, this is the 2 kg block, and this is a 1 kg block. Okay. So initially 2 kg is moving in this direction. So finally, after some point of time, 2 kg will be pushed back in the opposite direction. Similarly, 1 kg is moving in this direction. After some point of time, it will be pushed back in the opposite direction. So both are reciprocating in motion. Okay. Both are in reciprocating motion. So that means what you can say that Vp maximum, that is 15, that is in the forward direction. Similarly, in the other way, what you can say that Vpc max, that is 5, and that can has another value, that is the Vpc, which is equal to 5 in the opposite direction. Got it? So for this opposite component of velocity, but center of mass is not going to change. Center of mass velocity is not going to change. That is remains 10 meter per second along the forward direction. If I take these two combination, then that will be the value of Vp minimum. What is that Vp minimum number? That is 10 minus 5, that is 5 meter per second in this direction. Okay. So this is the range of speed for the 2 kg. Similarly, if I want to calculate the range of speed for the 1 kg, for 1 kg Vpc max, if I calculate the 1 kg, For 1 kg VPC max is how much? That is 0. Now, velocity of particle within the center of mass, that is equals to how much? That is equals to our 10. 10. No, 10 number, but it is in this direction. So once I am saying that VC is also 10. VC equals to 10 in the same direction, in the opposite direction. So if I add this two number, that is 0.
Yes, sir.
So for 1 kg VP, that minimum number is how much? 0. Okay. And what is the maximum? So maximum should be equal to how much? Now once in other situation, that this 10 kg will be in the reverse direction. This 10 is reverse direction. So that in that situation, so VPC, that is 1 kg moving in this direction. That is, this is the number of VPC number, that is 10. Why? Because VPC can alter the sign, but VC cannot. So you take 10 as one time positive, this 10 as one time negative. So once I take 10 as positive, so VC will be added with that. So for that situation, 10 plus 10 means 20. Okay. So this is the range of the 1 kg block. So finally your answer should be for 2 kg. For 2 kg, what is the range? Range is 5 to 15. Now, for 1 kg, what is the range? From 0 to 20. This will be your answer. Got it? So this is how you have to approach this. Okay, moving on. So let us practice this. So now say there are two particles. Two particles. So forget about the direction first. Forget about the direction. Use the 2 kg and 3 kg are moving. So simple way calculate the VC, center of mass velocity. That should be how much? Momentum for the 3 kg is minus 3 into 5. Momentum for 2 kg is plus 2 into 10. And divided by total mass is 3 plus 2. So that is 20 minus 15 divided by 5, 1 meter per second. Okay, and you are getting the positive number, that means it is in this direction. Center of mass is in this direction. Okay. Now for 3 kg. So for 3 kg, you want to calculate the range. So for 3 kg, one velocity is 5. If I say it is minus 5, so add it with plus 1. Nah. Because center of mass is not going to change, so that means you are getting the number as minus 4. Okay.
Okay.
Number is minus 4. Understood?
Yes, sir.
So, not minus 5, so, yes.
The left hand side is right.
So, for 3 kg, so first calculate the value of velocity. So, once you got the velocity of center of mass, now you are asked to calculate the velocity with respect to center of mass. Second step is, with respect to center of mass, you have to draw this. So, these are the two particles. They are connected in the string. Now, center of mass is moving in this direction, VC equals to 1. So, this particle is moving with the velocity how much? 9. 10 minus 1, 9. And this particle is minus 5 plus 1, this means this is 6. Okay. So, this is what? This is the velocity of particle with respect to C. And this is the velocity of particle with respect to C. So, now you can write the answer for 3 kg. For 3 kg, VPC is how much? VPC can be either plus 6 or minus 6. Now, VPC. So, plus 6 means it is moving in the forward direction. And VC is always equals to plus 1. So, if I add plus 6 plus 1, so it becomes how much? 7. Okay. So, VP or for 3 kg, VPC, VP maximum should be how much? Plus 6 plus 1, that is 7. What is VP minimum? Minus 6 plus 1.
Right.
Minus 6. But minus 5 is not the answer. So once you are getting the negative answer, make it at 0. Okay. So minimum cannot be negative. Minimum is 0. Okay. So this is the range of 3 kg. Similarly, range of 2 kg can also be calculated. So for 2 kg, VPC is what? VPC is 9. So it may be either plus 9 or it may be minus 9. Okay. And VC is how much? VC is again equals to plus 1. So make 9 plus 1, that is 10. So VP max is how much? 10. VP mean is 0. Because minus 9 plus 1 means minus 9 equals to 0. Okay. So final answer for this situation is the particle of 3 kg has maximum velocity of 7 and medium is 0. Okay, so range of speed for 3 kg should be how much? 0 to 7. And for 5 kg, sorry, for 2 kg, it should be equals to 0 to 10. So this will be your answer. Okay, and you also have to specify the direction. So whenever you are taking 7, so the particle is moving in the forward direction, that means in this direction. So 10 is also in the same direction. Okay, so in this way, you have to calculate the directions also. Okay. Now there is another kind of problem where you are asked to calculate the elongation. Okay. So in this situation, what is the problem? Problem is that there are two blocks. Now you are pulling one block with a 10 meter per second speed. Okay. And you are asked to calculate the maximum elongation in the string with respect to. So again, this is the method number 1. Now I am doing the entire problem with respect to ground reference by seeing the particle in a ground reference. So once I pull this 2 kg mass with a velocity of 10 meter per second, the spring will try to elongate. So once the spring will try to elongate, so spring will give a force kx in this direction, and this 1 kg is pulled by another force kx in the same opposite direction. So this kx will increase the velocity. Initially the velocity is 0. Okay, initially there is no velocity of the 1 kg, but because the spring force, the velocity starting from 0, it goes on increasing. Okay, it will increase. But due to this k, the 10 meter per second velocity is going to decrease. Why? Because it is retardative. So ultimately, the elongation will maximum when both of these two particles attain the same speed. Initially, 1 kg has 0 velocity and 2 kg has velocity of 10 meter per second. Due to the active spring force on the 2 kg, the velocity of 2 kg is going to decrease and velocity of 1 kg is going to increase. So 1 kg is going to increase means it will increase to a particular value of v, and 2 kg will decrease to a particular value of v, and at that point of time I can say the particle or the position is the maximum elongation position. Why? Because beyond that point v will further decrease. Beyond this point the v will further decrease and that v will further increase. This v will further. Now the spring is being compressed. Okay. So this is the position where the maximum elongation takes place. That means both the particles are moving with the same speed. Now, if that is the situation, so what is the initial kinetic energy? Initial kinetic energy is equal to half 2 into 10 square. Because I am calculating this with ground reference frame, so ultimately it becomes 100. So there is no elongation of the spring. So initial potential is 0. So finally, kinetic energy of the spring is how much? Kinetic energy of the system is how much? So both are moving with the same speed v. So that means half into 3 into v square. And what is the initial final potential energy? That should be, let us say, at this position, the spring is elongated by them. So initially the length is, let us say, this is the L naught number, natural length. So once I am getting the maximum elongation, let us say at this position the L naught plus xm is the length. So what is the elongation of the spring? That is the xm. That is the maximum elongation. So potential energy of the spring should be equal to half k. K is 100 into xm square. Okay. But there is another parameter v. So for that you have to do a momentum conservation. Net force on the system is 0 because the kx and kx will cancel out. So net force is 0. So you have to do the momentum conservation. So what is the momentum conservation? Initial momentum is how much? 2 kg into 10. 2 into 10 is the initial momentum. And that's because the final momentum means 2 plus 1 means 3 into v. That means v should be equal to 20 by 2. Okay. So this is the initial momentum and this is the final momentum. So if once I equate this to initial and final momentum, I am getting the value of v as 20 by 3. Now put it over there. So initially 100. So if I do the energy conservation, 100 should be equals to 3 by 2 into v square. V square means 20 by 3 whole square plus half into 100 into x square. Okay. So ultimately I am getting how much? This 2, there is 200 equals to 1 3 will cancel, so 400 by 3 plus 100 x square. Is 600 minus 400, 200 by 3. So 200 by 3, that should equal to 100 x square. X square equals to 1 by 3. So x becomes root of 1 by 3. Yeah. Root of 2 by 3. X is equals to root of 2 by 3. So that will be your answer. That will be your answer. So this is the maximum elongation. So this is the one way to approach the problem where I am applying the concept of energy conservation, energy conservation from the ground reference. Understood? Now the same problem can be calculated using the center of mass reference frame. Now with respect to center of mass, I want to calculate the initial kinetic energy. What is the initial kinetic energy with respect to center of mass frame? That should be equal to, I can apply the concept of half mu into V naught square number. What is mu? Mu is the reduced mass. That is half into 1 into 2 divided by 3 into 100. Okay. That means 2 cancels out. So 100 by 3 is the initial kinetic energy with respect to center of mass. Now finally, I know that both are moving the same speed. Both are moving the same speed. That means center of mass is moving also with the same speed v. Okay, then only it will be possible. Why? Because that v number, so if I calculate the center of mass velocity, what is the center of mass velocity? Velocity of center of mass should be equal to how much? 2 into 10 by 3. That means 20 by 3. Okay. Now if I do the momentum conservation, so I will get this v number is how much? Initial momentum is how much? That is 20. That should be equal to 3v. That means v equals to 20 by 3. That means the velocity that I am saying, it is on the block 2 kg and on the block 1 kg is there. These two velocities are nothing but the center of mass velocity. That always. Until and unless we go for the maximum elongation or maximum compression. Okay. So in this equation, if I say final kinetic energy is equal to center of mass, how much? So both are moving with v velocity and center of mass is also moving with velocity v. That means with respect to center of mass, they are at rest. With respect to center of mass, they are at rest. So final kinetic energy is 0. Okay. Only thing is the potential energy. Potential energy how much? Half a into x square. So only thing is this number should be equal to that number. Okay. So ultimately what I am getting that 100 by 3, that should be equal to half into 100 into x square. So 100 cancels out. So again x I am getting under 2 by 3. Okay. Same answer. Yes. It is easier. Okay. It is easier. So whenever the particles are moving the same speed, that means they should attain the velocity with respect to center of mass. Yeah, that is the same velocity. Okay.